In this short video, I'm going to walk through the basic process of working on the classification scheme and then the configuration of color ramps for a set of data that would be thematic. So in this case, essentially, this is a thematic map, and in this case, we're going to be using population density at the state level. And the reason I use state level, it'll help us see what happens in terms of, remember, we have 50 states, and we'll be able to count the number of states in a sense in each class, and we'll be able to understand what's going on. So the first thing I want to do is remember that we're going to be looking at the details component in our legend. And so here are our content area, and we have our population density. And so that is the layer that I'm going to be working with. So I'm going to click on that, and you'll notice that it has multiple data sets at different scales. And so remember, visibility scales, when I click on this, we can see that its visibility scale appears here, and we can set a visibility range. And you'll notice that the current scale is shown here, and then this is the range that the data will be available. In other words, these enumeration units will be available at. And so again, we can contract or expand those depending on what we want to do. What we're interested in this video is to look at how we're going to represent the data. So in this case, again, we're going to change the style. So I'm going to click on Style, and we're going to select which of the attributes. Remember, each of these polygons, states, has multiple attributes associated with it. So if you notice, I click on the drop down here, we can see that we have different years, population density per square mile in 2010, or the total population, the growth rate, household population, and then the 2016 population density. And so that's what I'm going to use today, and that's one that's highlighted. And in this case, I'm going to use a counts and amounts, which in another way of saying that is that I'm going to color each of the polygons based on a numeric value. So I'm going to select options here. And in this case, again, we're not going to normalize the data because it already is population density. That is population per square mile. So the normalization, if we were to have simple population, we might divide that by the area of each polygon. And so in this case, we don't have to do that. But what I do want to do is we're going to first look at the distribution. And we'll notice that the distribution here, if we look at the histogram, suggests that this data is very long tail towards the high end. In other words, the majority of our data values are in the smaller end, and then there are very few that have a high population density. Okay? And so again, we understand how that works. Now, our classification scheme, I'm going to do a couple of different ones of these so we understand kind of how they look. Remember, our data is skewed in one direction, so we want to see how that plays out. The first one, of course, would be an equal interval. In other words, an equal interval system simply takes the highest value and the lowest value and produces equal intervals based on the number of intervals. So if, for example, we had 0 to 100,000 and we had 5 intervals, well, each interval would have 20,000 in it. 0 to 20,000, 21 to 40,000, 41 to 60,000, etc. So we're going to start with that, and we're going to see what happens in terms of our data set. Choose that. And again, equal interval with 5 classes. And when I do this, click OK and Done, well, some kind of odd things happen. You'll notice that, in fact, in this case, it appears that when we look to our legend, that all of our states have an average density of the lowest category. And the question becomes, well, where is that high value? We look out to Alaska, and we look to Hawaii, and it doesn't appear there. So where is that very, very high value? We kind of have to look into that and see where that happens to be. Now what I'm going to do is we're going to go back to the details. I'm going to open up for U.S. population density. We're going to zoom out a little bit so those colors appear. And I have to look at the table and say, well, okay, we have that data, but we don't seem to see our value. And so here I'm going to click on it, go to state, and we're waiting for the table to come into play. and we ask the question within our population density, what is our range of values? And you'll notice that in this case there's something kind of strange about the data. 2016 population density, and in this case I'm going to sort descending, and we're going to look for, and it's going to take a moment for the data to populate, but there's clearly a data value that's skewing everything else. And there it is. So the District of Columbia has a population per square mile of 10,796. Well, that skews our data. Everything else, literally every other location, falls below that. And so every single state, with the exception of the District of Columbia, falls into our lowest category. So this isn't a terribly meaningful way of mapping our data. Now, an alternative approach in this case would be to use, again, same data set, but here we're going to look at our options, and again, our classification. We're going to choose the 2016 population density, and this time we're going to classify it rather than by equal interval, which we know isn't going to work. We're going to change this to a quantile, and that means that there's going to be an equal number of enumeration units in each category. Now, what ends up happening is virtually all of the higher values, you'll notice that 10,000 really doesn't affect it, because in fact it goes from 286 up. But what this does is you will note that in this highest category we can count our states. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then in here we have the District of Columbia, which would be our 10th state. And over here in our lowest categories, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so we can kind of see how this works in terms of our classification. Equal number of enumeration units in each category. It also allows us to say the top 20% of the states and the lowest 20% of the states. Now I'm going to change one more thing. We're going to leave it in a quantile category here. But what I want to do now is I'm going to change, in this case, our colors of classification. And so you'll notice here that I have a quantile, and we also now have a symbol. So I'm going to click on the change symbol because I don't particularly like that blue theme. But remember that this is a single value, and we're going from the lowest value to the highest value, so we want a monochromatic scheme. And so in this case I'm going to choose somewhat of a more orange color ramp, and I'm going to click OK. And you'll notice that again we can change our color of our symbolization. We can also change our symbols here in terms of editing the labels. We could actually change what the labels say. For example, we could add per square mile to this label. Okay, so again, that's how we change a basic classification scheme. Now, another alternative to this would be a counts and mounts based on a graduated symbol, and we'll be discussing that in the next video. So we'll see you then.